Hi everyone, and welcome back to the second session of SyysGraph 2012. I apologize for the loss of my voice. I think I have some explaining to do back home, trying to tell my better half that I lost my voice trying to keep a Turkish Airlines plane in the air. She's not going to believe it. Anyway, we're going to start out by having a very quick word from our sponsor, Jason Ball from Qualcomm Ventures. Welcome.
Is this mic on? Great. Hi, Jason Ball from Qualcomm Ventures. This is the second year I've come to Slush. I was here about 3 years ago, and I have to say I'm extremely impressed with the progress. It's amazing how many people are here. I just want to talk a few minutes about Qualcomm Ventures and what we do. Qualcomm, the parent company, is the largest wireless chipset company in the world. Qualcomm Ventures, we've been around for 12 years. We've been in Europe for 6 years. I'm actually based in London, so it was only a 2.5-hour flight to get here this morning. As a group, we're looking at all things across the wireless ecosystem. For me personally, I'm looking at basically software, services, apps, and of course gaming, which is why I wanted to come here and have a chat with you this morning. We have 10 portfolio companies in Europe so far. There are just 2 of us on the ground here. We're making investments. So again, across the entire spectrum, we're looking at very early stage companies. So we'll make a 100,000 euro check into a company, and we'll also do a 5 or 10 million euro check into a company, depending on that business and its stage of life, et cetera. One of our last investments was a company called Gaikai. It's also one that we exited earlier this year. So I'm very happy with that. And Qualcomm Ventures, as an investor in your business, where we can actually help is for chipsets, 2 things really matter, either video or gaming, and these are 2 key areas we can help you on the technological front. If you'd like to get in touch with me, here's my email. I'm also available on Twitter, Jason Ball. Thanks.
Okay, so our next speaker is Dr. Jaakko Lehtinen, or Jake, as we call him in the Helsinki graphics mafia. And he's got a fascinating background, starting in the mid-90s, building the graphics technology at Remedy for games like Max Payne and Alan Wake, followed by a PhD in computer graphics at the Helsinki University of Technology, a postdoc at MIT, and later working as a senior research scientist at NVIDIA Research. He's also the brand new assistant professor of computer graphics at Aalto University.
Right, so thank you, Vili, for the introduction. Now, you all are probably here, like me, because you do graphics and you like to know what's going on. But who am I? Well, Willie actually said most of those things, but I'm going to do another recap in about 1 minute. So I started coding up graphics stuff as a teenager, as a hobby. And right after high school, I went to work for Remedy, the game studio. I had my hand in the Max Payne technology and also the technology in Alan Wake. Now, a key moment was that at Remedy, while building the technology for those games, we found out that we'd actually rediscovered some algorithms for doing global illumination that were actually published in the academic literature in the 80s. Now, it's a really long story, but I'll cut it short and say that this was so interesting that it made me and 4 colleagues want to go do a PhD in computer graphics at the Helsinki University of Technology. Now, this was like kind of a hard proposition at the time because there was no one there who was doing graphics on the research side. But luckily, Professor Lauri Savioja, who I think is here in the audience today, took us under his wing, even though graphics is not his cup of tea. So we went on and did our PhDs working together among 4 fantastic people. So after my defense in 2007, I went to MIT to work with Professor Fredo Durand as a postdoctoral associate for 3 fantastic years. And after that, I came back to Helsinki to work for NVIDIA Research. with a dream team that consists of Timo Aila, Samuli Laine, and Tero Karras. Now, that's all fine, but why does all this matter? And furthermore, what does it even mean to do academic research? A lot of you probably working in the industry think it's just waving your hands and getting paid for doing nothing. But I think you'd be wrong. And let me give you my perspective why I think you'd be wrong if you thought that. Now, this clearly is a tree that's sideways. And still clearly, this is an inverted tree that's sideways. I'm going to use it to illustrate the progress of knowledge. Now let these dots illustrate where the current state of the art in the applications is. Think of games, movies, wherever you might actually apply graphics, or any technology for a broader picture. Now the path to where we are currently at the state of the art in the applications is traced out by, we build on previous stuff, and that's how you advance. So when you do something new, you build on the state of the art and nudge it forward, and now you've expanded the horizon of where technology is today. Now, what's wrong with this picture? Clearly, if we only look at where the industry is now and where it's been coming from, we don't actually know that there's a whole tree out there. We have kind of a myopic vision. The current state of the art certainly points the ways that we might want to go forward in the future, of course. And I'm not saying there's no innovation in the industry, of course, far from it. But I'm saying that this innovation usually builds on sort of a short-term constrained situation, because you have to build on something that you already have. You can't scrap everything and build something new because you have products to ship, right? So what I am saying is that sometimes there are larger rewards waiting for out there, but they may be of the nature that you can't actually think of them given the constraints of where your technology is currently. Given that you really have to produce those products at a fast pace to keep up with the competition. And everybody who's worked in the industry knows this as a painful fact, of course. And this applies on many timescales as well. Now, it is precisely the job of research to trace out these paths, these hypothetical paths, to find new ideas and act as a beacon for applications in the state of the art to look forward to or look ahead to map out the roads, so to speak, so that you have a broader horizon on stuff that you might actually want to be doing in the future, after your next product or your product plus one and so forth. Now, of course, it'd be naive to think that research in the academia would solve all problems. Clearly not. Even if we somehow magically manage to trace out all these paths in advance, it turns out that many of them will never, ever lead to new applications or advancement in the state of the art. They turn out to be dead ends in this tree. But here's the catch. That's something you can't tell in advance. You never can. In fact, some of the biggest practical algorithms today in graphics have been proposed 20 or even 30 years ago when they were totally impractical, and the people who came up with them could have been called, hand wavers and so forth, from a purely short-term perspective. What is a good answer to a given solution or a problem changes over time as our minds and machines evolve. Like, for instance, machines are a lot more parallel these days than they used to be in the past. And this is really a big game changer for a lot of algorithms out there. You really have to fundamentally rethink how you solve a given problem in code. And this is something that if nobody had thought of this problem beforehand, we'd all be lost right now. But thankfully people had, and we're not lost. Heck, even the Z buffer, if you know graphics, rendering algorithms, was thought to be a completely outrageous idea in the 70s. They said, Ed, that thing's never going to work. It requires, hundreds of kilobytes of memory. How could it ever work? But yet, look at what happened. So why am I talking about this? I left out one bit of personal history that Willie mentioned already, which is that in September I started at Aalto as the first ever professor in Finland to specialize in the technical aspects of computer graphics. I still work with NVIDIA research as well. I'd be crazy not to, given the talent and fun we're having there. Excuse me. Now, what do professors do? They teach and do research. I talked about research before. As a faculty member, you work on the frontiers of that research, of that tree, the current visible top of it. And that's what I've been doing with, for the past few years with some success with an incredible group of colleagues. Just to give you a flavor, we do stuff like we take a bad picture like this. Using the same information, we can turn it into a much, much better picture using much less computation that would be normally required. Here's another example. Clearly not very usable. Our algorithm, based on the same information, gives you this picture. So that's just the flavor. Now, I'm really excited about all that stuff, but what about the other part, teaching? What's kind of rare for a professor, I've also done stuff at the cutting edge of the applications. And this combination, I believe, is a big deal. I'm in the process of revamping the entire graphics teaching or curriculum at Aalto, already underway in this year's Introduction to Graphics class. And I'm making it more modern and rooted in what's important in today's applications, while remaining general in the sense that I'm trying really hard to teach understanding instead of tricks. This, I believe, is really crucial in university education. My goal is that the students, when they take graphics with me, they get a basis that helps them really push their way towards working at the state-of-the-art level in practice. Of course, no school can give you this, you have to work hard for it, but it matters a lot what kind of push you give. And for those students who are more inquisitive, I really want to help them on their own personal journey towards the frontiers of this tree of knowledge, where the mythical PhD lies, together with my fellow senior research scientist at the NVIDIA community. It's the first time ever in Finland now where there's an actual community that, and a well-defined path towards this goal. So if you're interested in this, you can come work with us. Doing a PhD is really about changing the way you think about problems. You let go of stuff fed to you by other people. Instead, you build on it and make it better. And even if you go to choose to go do applications afterwards, a good grad student will have, at the end of his studies, an arsenal of tools that's far more powerful than any that you would have ever had the time to develop if you only worked on the applications under the pressure of production deadlines. Of course, there's still lots of learning to be done in the trenches when you actually ship those products, but this combination is, I believe, is really, really something to strive for. Now, why would you care about any of this? First of all, most of you apply graphics in your work. I'd love to hear about you, what you do, get your perspective on what is important for you technically. This will, of course, help me tune my teaching, and hearing about your problems will help me steer my research directions. Maybe we can work on stuff together. This is something that's actually very real. Our recent work on material appearance acquisition is prompted directly by production problems at AAA games, but still we push the envelope on the research academic side as well. So sometimes these frontiers can actually be quite close to each other. And of course, if you should you be hiring, I'll be happy to direct my brightest students your way. So with that, it's time to thank you, time to crank up the stereo in our Roadster. I know it's highly figurative in Helsinki in November, and go do more cool stuff. Thanks. If there are time for questions, I'd still like to advertise a fantastically interesting talk at Aalto. Can you please show the slide still? Given by my former boss from MIT on December 4. Okay, thanks.
Uldis. Yeah, the next one on stage is Uldis Leiterts, and he's the co-founder at Infogr.am from Latvia. And Uldis will tell about the challenges running a design-driven startup and share a story from failing the last year's Slush startup competition to becoming the world's largest data visualization community.
Minor technical problem here.
You have a clicker, right?
Yes,
It's supposed to work.
it's supposed to work.
Amazing. Hello.
Please stop the timer.
Okay, hi. I'm Olli from Infogr.am. It's a web-based tool for data visualization. And I'm going to tell you a story which started exactly a year ago here in Slush. And before that, it became infographics community, which is widely used by journalists and bloggers. I was employee in Baltic's largest news company. And basically, the story goes back in my childhood. I was expected to be a journalist, but I didn't like the story of me being a journalist. So I said, no way I can work in media. And I ended up being a designer in a newsroom for about 10 years. And with my co-founder, we were responsible for a couple of interesting projects there, which ended up being semi-related to data visualization. That was about the last summer, and people get excited about big data. And we thought we just want to be part of that. It's so amazing if you see Hans Rosling presentations and all those things that people can do with data. I mean, that's so amazing, and we just want to be part of this emerging potential that you can do is when you can work with visualized information. And so what we could potentially do is that, and one thing that would catch your attention is infographics. I mean, this is Google Trends for the word infographics. In about 2011 or 2010, it just started to take off. It's a pretty hard thing, so everyone's trying to make those. But, I mean, okay, here's a graphic design oriented conference, so maybe I would like to ask you, how many of you have ever tried to make an infographic? Amazingly a lot. Okay, usually it's a couple of hands actually, and there's people who do, okay, how many of you outsourced making infographics to someone else? Yeah, you're the right crowd to make those. Usually it's pretty challenging for those people who don't have a graphic design background to do that. So journalists and those people who publish information online, they could use some help. So we decided to create a tool that they can use themselves without having graphic design knowledge. And that's how Infogr.am started. It's a do-it-yourself web application for making infographics and interactive charts. It just takes about a few minutes. So what a user does there, it just picks a template. And it's simple to customize the data. Or just basically, we preload a lot of designs. So you choose one you like, you customize the data, it's a simple drag and drop interface. There's no way to create anything ugly with the tool. Then you can publish that online. It's animated, it's interactive, and that's the result. It takes about 2 minutes to do, and it's been quite well received over the industry. I put some quotes, so the next web wrote that its application is absolutely awesome. Part of Infogr.am's charm is it doesn't offer many opportunities to screw up. Never share a boring spreadsheet again. And there was another one which I totally like. It makes spreadsheet enjoyable. Now, I just took a list of 200 top users we had and parsed out a couple of few media companies using us right now. We have 150,000 journalists and bloggers that trust us with their stories. And they have created 250,000 infographics. That is the largest number of infographics produced by any tool on the web. And if you look at the number in perspective, over the last month, they created almost 100,000 infographics. So just doubles every month or so. We currently reach more than 500,000 people by the content created by our users and embedded third-party websites. So it actually is a big media company. Although it take a couple of months for us to potentially become, but we quitted our job in March this year. And by December, we will reach more people than the news company we worked for, which was the largest in Baltics. Now, another story about Slush. Last year, Slush was the first conference I ever presented to. And that was amazing. I collected more than 100 business cards. More than 10 of those were for VCs. Nobody ever replied to me, actually. But I got a cool answer on 31st of December from one of them, saying, sorry for not having time to reply, maybe next year. Basically, afterwards, let's just go back. After Slush, we got seed investment from HackForward, which is one of the leading European startup accelerators. We're also alumni of Startup Sana, and we're doing very well. So I'm really thankful for the great conference, Slush. That was a great, inspiring event last year, and this is where we started. Another thing that I want to share is design thinking we have behind Infogr.am. So if you take news publishing industry, the journalists historically always had a photographer with them, and hey, go grab a picture of that guy, or there's a house burning, take a picture of that. So they always had someone to take care of the graphics. There is basically a natural need for them, someone else to do those things. So they don't do things themselves, they're writing the stories. And we respect them for that, for the reason they are writing amazing stories. So how can we, but there's one more thing that they totally hate, and they hate technology for that the same reason. And there's just one thing that they hate more than technology is their own IT department. So when they have to go to their own IT department and ask people to, can you make a visualization of that one? So we decided to make something that is so easy to use that would be more easy to make it themselves than to go to IT department to ask anyone else to do that. You still have to make something in a spreadsheet and email that to someone and say, well, can you visualize that? Now it's easier to do it in Infogr.am. Another thing which we didn't want to take with us from the corporate backgrounds we all have in a team, we hated to go to jobs, had to go to work. We hated to wake up every morning and be expected to be in a workplace for a certain time. And we were expected to meet certain deadlines on a project that didn't make sense. So we created a culture within Infogr.am where we don't have a specifically limited place to work. You can work wherever you like. We've learned that it's easier to work together in the same room, but nobody's forcing you to do that. We also don't have titles, so if you go out for a meeting, you're fine to create a title for yourself. So anyone can be a CEO today if it's fine. We wanted to create an environment where people who are involved in a team, especially in a startup team where everything is changing, are involved in all the processes. So designers are involved in both technical processes and business processes. So all those things are interconnected, and that makes the company really strong. We did a couple of major launches this year, and we have still a lot of things to work on. And I believe you will hear about us on our couple of next month. Thank you very much.
Okay. Actually, next one up should be Antti. Yeah. Yeah. So next one up is Antti Laiho. He's a lecturer from Metropolia, and he visited the SyysGraph 2012 conference last summer, and he's going to share some of the photos and videos he took over there.
Okay, nice to see you. I really went to this SyysGraph, and it was really kind of a blast. And now I try to give you a little wrap up what I saw there, what I experienced, and so on. And first of all, what is this SyysGraph in stage? It's art. It's about technology. It's about having fun, new things, and so on. So it's really worth. And I have some pictures and I have a couple of videos. And here you can see just a short wrap up. First of all, what I saw there, the 3D printing, it's growing, it's becoming more major, it's becoming hopefully more cheaper and so on. What I saw also is Unity is getting much more attention, so people are considering that quite a lot, and it's amazing piece of game development. Lots of stuff done with Kinect, so that was also one thing. And if you're doing 3D, there is more and more real-time rendering engines coming that are using GPU, not only CPU, but also GPU or both. And they are pretty fast, even though the real-time rendering has been around for 10 or 15 years, it's becoming more and more for everybody. And there was lots of students. Any students here? Raise your hand. Use some calories? Yeah? Okay, good. Okay. So there was lots of students, and there was also schools to promoting themselves and getting more students to their schools. And as a student, I recommend to consider this SyysGraph student volunteer, because you get there, you work a little bit, but you will get the conference for free. So I think that's a really good chance to go there and as a student learn more and so on. There is a section of emerging technologies, where is new technology coming and all cool gadgets and so on. So that's a really nice thing. I will show you some pictures. And then there is electronic theater. That's where is a lot of animations for students for different companies and games and so on. So that's also really great. That's what looks inside. There's much more. But there were some dead people too. Not totally, but they were working too much. There was effects and so on. But let's go forward. There was a keynote speaker. It's a little bit dark, but keynote speaker Jane McConigal was talking about gaming and how the game changed our life. So, for example, if you think by one study, when you have played games, by average person has played games of 10,000 hours before the age 21. Think about it. And the idea was that how could you use that 10,000 hours to use something more kind of games? How can you improve people's life with playing games? And there was one really interesting aspect that when you play games, gamers spend 80% of the time failing. Think about it. You fail all the time. Yeah, every time you play. But there was also one thing. By a study, the gaming, if you have this, anybody has this ADHD? Yeah? So if you have this ADHD, then it will help you symptoms a little bit, hopefully. So I recommend you to play more games. But then one thing is that by a study, when you play games, your brains have some actions in there. There are some connections going and so on. But your brains doesn't work that well only when you level up or if your character gets a new item or something. But when you try something new, then your brain starts going, if you think about it. So don't just do something that you have done before, but do something new and try different things when you're gaming and playing. Then about 3D printing. Yep, it's printed in 3D. So, and now someone is thinking, does it do that colors too? No, it doesn't. Well, some of do, but this is hand-painted afterwards. So it's pretty cool. It's something like 30 centimeters. So these were really great. This is from the movie John Carter. The same. Looks cool. There's some hairs too. Not printed. afterwards put there. Close shot. Yep. Halt. So the size of this was something like 70 centimeters or something. So it was quite huge. And I asked these printing machines, 3D printing machines, the price range was something like 30,000 to 150,000. So not everybody has afforded that one yet, but hopefully soon. Okay. Of course, there was a little bit cheaper ones, and you can try to print your own things if you want. Then there was interesting things. There was this kind of fabric, so if you touch it, it will leave a white mark, and the white stripes, if you can see there somewhere, this will travel around the fabric, and I don't know how it worked, but it was quite nice. This was done with using the Kinect. So there was Kinect, and there was this blue spot, and the task was to throw these foam cubes you can see on the right side of the image, and you have to hit this blue spot, and it's all the time moving, and this white thing underneath is little small these Styrox balls, and when you hit it, yeah, I don't know, something happens, it blows air, and stuff flows, and there is lights and music and stuff. So it was pretty cool. This was really cool. Oh, the time comes fast. So this was really cool. I'm not going to play this video, but there is a robot, and there is a person controlling that robot over there with a helmet and gloves. And when you move, you can really see through the robot. And this thing was that you can kind of a virtual presence. If you have to be a meeting somewhere and you can't go there, can be only a robot, and you can really control it, and you can take stuff and so on. And it worked really well. And the field of view was really large. And I like that, so because as a teacher, if I'm really tired, in the future, I don't have to go to the classroom. Instead, there could be just a robot, and I could be at home with my helmet and my gloves, and I could do the teaching from there. It would be so awesome. And think about it, if all the students, they have also those, so the classroom would be full of robots, and we would be at home and doing the learning and stuff. So, how cool. Next one, there was this device, so when you press something from the keyboard, it will bend your finger. Oh my God, it gives you some electricity to your bone or your flesh. I was a little bit afraid of that, but so you can do all your finger movements with that, just pressing the keyboard. But the next one was chili chair, and this was like electric chair when you can sit there, and their study was to study how people are afraid. Are you afraid if they put electricity in your hand so your hair can kind of go up? And do you really feel you're afraid? And I went there, of course, I have to write down that they are not responsible of my death or something, because if they put something there and I had something happens to me, then yeah, you know. But anyway, it worked kind of, but I wasn't that afraid. Well, unless if they increase the voltage, I could be a little bit afraid. But anyway, it was quite cool. This was also a nice thing. There is a little device that plays notes, and when you pull it like this, it plays the notes on this paper, and you can change the instrument and so on. If I have time later, I will show you the video. And that was actually, there's multiple people doing like an orchestra. So basically, if you have 50 people doing this on a paper, you can have some kind of more music done. And there was this kind of device where it somehow makes this heat-sensitive painting on an object. So you can paint anything basically on object, and it will vanish when it freezes. So basically unusable in Finland. But anyway, it was still cool. There were small cups, 10 seconds, oh my God. So small cups, and when you shake in one, you have something there. There was line going to another cup. You can feel that also in there. And you can pose your characters with just posing a doll, so it worked quite nice. Eye asteroids with just using your eyes. And there was a chip for plants, and when you touch it, it feels and it gives some kind of flames or something into this reflecting picture. There was good food. I gained 5 kilograms in 3 weeks, and that's it. Thank you. It was a little bit fast. Okay.
Okay, thanks, Antti. Next up, we have Tomas Westerholm. He's the founder and CEO of 3D Render Ltd, and he'll demonstrate the power of RenderLite software in architectural visualization.
Hello, everybody. Nice to see you here. I will talk about 2 software that we are working on. The first one is the RenderLites. You will see a 10 minutes clip running on the background. And the other one is a cloud service called SkyHigh. I have devoted my life for architectural visualization. It all started 1977 when I was 6 years old. I walked to my parents with a pile of paper on my hands. I had just learned to draw a perspective. I had drawn a kind of storyboard of a journey inside a space station, and my parents were looking it a bit astonished, and they asked me whether I was about to become an architect as an adult. I told them that I would rather like to drive locomotives. Eventually I graduated, but I have never built a real building. I have consulted more than 1,000 architectural projects, but I have never built so far a building. Only one exception, a 9 square meters extension to a horse stable in Nastola. This software is about global illumination happening in real time. This has been our dream for almost 20 years, to get to a situation where you can model architecture, bring in CAD models and convert them in real time into good enough presentations. I know that there is a strong competition going on a GPU calculation, that you want to do everything in pixel-wise perfect presentation. This software, this SDK, that is the kind of game engine core, is doing it on a vertex level. We are storing the energy of light in vertex points and then just blending and bleeding it around the scene. And that works well enough for us. This has been used for 2 years in several productions. We are really happy with the software, but we still need to improve a lot, and especially the workflow and user interface needs to get better. But the real need is there. We waited long for this kind of engine to appear to the market. Eventually, after a strong frustration, we started to work on it. We found the proper SDK, and we were able to pull it up to this level. And now, at the same time, there is now the competition. There are few similar software. They're a bit different, but they are all targeting the same market. The other software I mentioned, or cloud service called SkyHigh, is about improving the whole business process that we have been involved with. We believe that nowadays the tools are pretty much good enough. The customers are not anymore complaining about the visual quality. They now ask us to make things faster, more precise, cheaper, so on. So what we are facing actually nowadays is more like the delivery process, streamlining that, making the workflow happen better and faster. And that brings us to the logistics and information handling. We believe that this is a matter of communicating between brains. We need to be able to deliver proper information in proper context. And for that, we are working on a different application, which is about connecting the workflow deep enough into the native CAD programs over the cloud, back to different interfaces on mobile devices, so that eventually one day, when you're about to order architectural visualization, all you need to do is to express your need, either by speaking or writing. And from that on, we know what to do. You need to provide us some ideas, and we will provide you with visual content in a best possible workflow. Some projects that we have done over the history have been quite interesting. An example of getting a business park proposal. I got a phone call to the office that, yes, can you help us? We need to visualize a business park. I thought, well, yeah, can you send us the material? No, we don't have any material. Then I thought, well, how can we do it? Well, I will just explain you what to do. So I got instructions over the phone. You have to put there 3 floors, 4 buildings, steel, wood, glass, and be fast. We need the pictures in the evening. So we started to work on it. The whole team was working on it, and after the lunch break, we had the first review version to be sent. We sent it to the customer. He called right away back and told that, okay, this is fine. Just split some of the facades to shorter segments and add there a couple of balconies for smokers, and then it's done. And the project is built today. So in the very hectic, in the very fast moments, we have learned to be really fast. We need really fast tools, and we understand how this business really operates when it comes to decide whether people want to invest money into constructions or something else. Practically, construction business, in the end, is only about investing money. People think that they get average 6% annual yield on the investment, and then they get to decide whether it is today constructions or something else. I have a list of features for render lights. You probably see something. There is displacement mapping in place. All kind of reflections are supported. There is real-time ray tracing happening. We can run everything in stereo modes, in several standard stereographic modes. It works very well. And you have a lot of controls and buttons. Luckily, you don't see them here right now because it is professional software currently. We would like to make it even easier to use and find more audience, more users than just the construction industry. It could be used in advertising world, movie, film world, and so on. I welcome you to download the trial version and familiarize with the software. Thank you.
All right, thanks, Tomas. And next up is Dr. Tuomas J. Lukka. He's a curious cat as well. I mean, he got his PhD, I believe, in quantum physics at the ripe age of 19. Did his postdoc in, pardon me? 20, damn. Did his postdoc in Princeton and came to the conclusion that he knows everything that one needs to know about quantum mechanics. So he decided to tackle something really hard and moved over to computer graphics. And for the last couple of years, he's been going even further to work on some of the big challenges in computer vision and robotics, and he's the chief scientist at ZenRobotics.
Hello. So, I'm Tuomas Lukka, and thanks, Vili. The place was actually Harvard, not Princeton, also, but never mind. I'm going to talk just a little bit about data and what's happening with data at ZenRobotics. But first, a little bit about what is it that we do. We have one product. The product is the ZenRobotics Recycler, which is the world's first robotic waste sorting system. So what you have here is that you have mixed waste going in. You have a bunch of sensors, after which you have the brain interpreting the results from those sensors and deciding what this robotic arm should be doing. And the robotic arm picks up objects from here and throws them to the corresponding bins. Of course, because it's waste, you cannot always reclaim everything. So some of the stuff will go to reject and will go back to the waste landfill. This is the same, basically the same that you saw in the previous slide, from a different angle. This is the actual robot at Viikki in Helsinki. We are running a production runs there every day. So, what does this robot actually do, this system? This is the stuff that goes in. Let's take a briefly closer look. So, here you see, this is the kind of stuff that gets fed onto the conveyor. There you can see that there are various things there, plastic cups, pipes, board, silicone tubes, whatever. And this is what comes out. Metal, wood, and stone. These photographs are from the actual bins that our robot has sorted. So we have actually gone from here to here completely automatically. So why is this interesting and important? Well, this is how it's done today. I was actually very surprised when I was entering this field and learned that this is actually really what many people have as their day job is standing on this line and picking various usable pieces from the conveyor and throwing them in the shafts that you see here. This is something that it's not a very it's not a job that humans should be doing, in our company's opinion. And because of that, we do want to automatize it. Why is this the world's first robotic recycling system? That's because something was missing beforehand. I mean, robots have been there for all along. Cameras, sensors, they have been there for a long time. But going from the sensory inputs to what the robot actually should move, the way it should move, is actually a really complicated problem. For humans, it's trivial because we have evolved for a long time in the real environment. But for computers, this is actually a really hard problem. Because if you imagine that you're only getting the numbers from the camera's input and not the picture, you can get a point of why it's difficult. But why is this so difficult problem? Why is waste difficult? Well, waste is all kinds of stuff that's just really, really mixed up. Waste changes over time. So the waste you have today is going to be different from the waste you will have 5 years from now. If you make a system today, it's going to be not working so well in 5 years. As you can see here, the materials used in construction and demolition, the type of waste that we are handling is construction and demolition waste, I forgot to mention. The type of construction has changed a lot and will keep changing. There will be new products that look completely different than the ones that were before used. It also changes over time at a much shorter period. So when the season gets wintry or slushy, it's going to affect the input that you get. You're going to have the same boards, but they're going to be covered in ice, which changes the identification quite a bit. Objects that are in the waste, they can be deformed. Like this is a basket, but it's not really shaped like a basket anymore. Or you have this bottle that was a certain shape, but it's not anymore that shape. Objects can be broken. I mean, we all recognize what this is, but that's a bit difficult for computers at the moment. Objects can be dirty. I mean, one of the methods that is used in the field is spectroscopy. So you see what color the object is, but once the objects are covered in this dirt, the color is not at all so easy to see. Or then, for example, these. We are picking wood, stone, and metal. Where would you put these objects? I actually myself don't have any idea if this should go to one of these bins or not. I mean, there's always really weird stuff in waste. There's a football in construction waste. There's always... This is the stuff that you see on the real conveyor at Viikki. Some of it is pretty familiar. And should this go to wood? That depends on what your purity requirements are. And you're probably not going to see too many of these, but it always sometimes comes and will ruin your load if you're not careful. And this is my favorite. Kuuluuko perustuslain tulkintatoimen teoriaan synteettisten tulkintaproposyyden välttämisen periaate? This is also authentic picture from Viikki, from construction waste. So to get back on the more technical side, so in geek speak, waste, it's non-stationary. The distributions are not stationary. It's all the time changing a little bit. It's not the same tomorrow as it was yesterday. It's power law distributed. This means that there are always going to be those rare outliers, or actually not so rare. That's the point of outliers, that they are not as rare as they would be if you had normal distributions everywhere. So you can't really predict what's going to happen in a year if you have only run for a month, because there will be events that are weirder than what you have seen yet. And it's complex. And how do you classify something like that? Well, our answer is data. Lots and lots of data. We can put in practically any sensors we like. We have a RGB height map. We have hyperspectral imaging. We also have a metal detector. So here I will show a little piece of the conveyor from different sensors. This is the camera. Basically, that's just normal RGB picture of this waste. This is the height map of the same. There are some pixels here where we didn't have enough remission to get a good height map reading. This is the metal detector of this waste. So curiously, there is actually some metal in this lump that you probably wouldn't expect to have there. And then start the hyperspectral images. Here you can see the changes, which happen here. And you can measure a lot of data like this, but how do you interpret it? You have two basic approaches. You can try to model everything in the world, or you can just try to learn from examples like humans do, and that's what we do. But there's a lot of this data, 20 gigabytes per hour of operation. So this is really big. And we only need to store a part, though, because only the ones that humans have shown what it is. And after that, we use the data to teach the machine learning algorithms, but that's something that I won't go to here at all. And I was asked also to mention that we are hiring at the moment. Thank you.
All right, thanks, Tuomas. Next up is Lasse Louhento. He heads up the Clash of Clans development at the gaming company SuperCell, and he's a long-time industry veteran, having worked in games for over 20 years.
Hello. One, two, yeah.
It's going automatic. I'll do it manually. Manual overdrive. There's a lot of slides. Okay, how's it going? My name is Lasse Louhento, and I'm here to talk about some barbarian stuff. Let's start. Because this is my first time in stage, in any stage, I use this opportunity rudely to boost my ego, like it's common in these parties. So 20 years of experience of creating games, from sort of Amiga days to Sega Saturn, PS1, PS2, Xbox, and blah blah blah. Social platforms, Facebook, and so forth, and then finally landing on the iOS and touch devices. I started off as a graphic artist. But the last sort of 4 years, I've been producing games, or at least trying to produce games. And then, yeah, the last one. Okay, so the purpose of this talk is because it's a SyysGraph, and even though I would love to talk about the Clash of Clans and how it kind of, the birth of Clash of Clans, this is sort of oriented to the graphical bit. So the starting point on the graphical side was to just a few things. So really, one of the things is, we really focused on the playability over anything kind of nitty-gritty details. Like, I know you guys are really into graphics and shaders and all that stuff, but we kind of skipped that part and, really focused on the playability. To us, the playability is everything. So the objects sort of should feel like chunky and kind of like almost like a pieces of Monopoly or, board game pieces. Also, we tried to create an art style that would appeal to a sort of wide range of players, not just the fans of this particular genre. Because if you look at our app store, there's a PvP games, and they really target to a niche audience, like, ooh, there's a big sword and muscles, and it's a bit lame in that sense. But we really wanted to have a wide range of players that could enjoy Clash. Everything is designed for the touch UI. We have this mantra, so like tablet first, but it is really, really important when you look at it. When we kind of made the kind of SuperCell pivot to go for apps, iOS market, we looked at the competitors, and there were a lot of games doing ports. So this is a Facebook port, this simulation game, and you could see double tapping and all kinds of crazy stuff. We really didn't like what we saw, and saw a big opportunity. Really, if you take that touch and just utilize it the best. Yeah, unique art style wouldn't hurt either. So there's a lot of copycat stuff at the moment. And we were kind of dumb enough to we set ourselves to do an RTS game, and we wanted to do 10 different characters, and we had a really, really small team. And by small team, I mean we have a team of 5, not 50, not 500. We have a team of 5. So there's like 2 client programmers, 1 server guy, and 1 artist, and then myself doing what I can to do. We also wanted to do this super quick. In the end, it took us 6 months from get-go. So all the sort of technology was built, all that stuff. So we went to beta in Canada in 6 months. Also, one thing that made this kind of project a bit unique, we didn't have a game designer, which is a bit ludicrous if you've been doing the games. It's a bit like, where'd you go from there? But really worked as almost like a band, like gelled as a band. Everybody contributing ideas to each other, and it really worked. We had a super team, and you can't just pull it off with any sort of 5 people. You really have sort of top people. All right. Okay, so here is the... oh, Jesus, it's really blurry. Anyway, this is the first sketch that was ever made of Clash of Clans. As you can see, we really want to have a high camera angle, isometric stuff. You know, because it's an isometric thing, we kind of based on, yeah, maybe the grid will work. Maybe we'll do chamfered squares, the kind of shape language of the models. Everything is pre-rendered, minimalistic on detail, chunky on design. But we really wanted to get the barbarian right. This is the kind of mantra that I was really kind of going over and over and over again. We really need to get that bloody barbarian right. And if you think of barbarians, if you ask what people think about barbarians, they think of greasy, oily men like Conan or you know, things like that. But we kind of wanted to change their mindset, add more humor, you know, how squared, how Lego-ish the character should be. We benchmarked a lot of iOS games. They were sort of cutesy, and we were kind of like, maybe it's time to really do cutesy characters. I pitched this idea to Ilkka, our CEO. How about this kind of lovable, huggable barbarian? He loved it. He loved it. I think it's a kind of like a nice contrast between what you think of barbarians are. Yeah. So also parallel to this, we also once we started to do the barbarian, we also run these kind of icon tests. So whenever we had the kind of barbarian ready, we put it to a sort of icon form, see how it sort of look and feel, because if you think about it, the icon in the App Store is one of the most important things. Also the name is pretty important too. So we went into these fake sort of prototypes, and constantly while doing this, we were looking for the name for the game. And oh man, this was a hard process. The name it was like the last week we nailed that name. So everything looked really pretty good at this point. We were pretty happy with the art style. Things were moving fast. You know, the coders were crazy coding like all the time, like mad. Started to sketch out the different characters because now we had the barbarian, you know, doing the goblin, doing the wizard, doing the archers, all that stuff. Environments, buildings, you know, all that stuff. We also had the soundscape, which I think is really important. It's the audio-visual package, not just the graphic stuff. It needs to gel together. So everything was kind of done. You know, things looking pretty sweet. Or was it really? You know, once everything got into place, this is a really blurry, really bad monitors. When everything was in together, we kind of saw like, this is really it's quite cutesy that we're doing. All of a sudden, you know, it didn't really feel like, yeah, it's going to be a PvP, meaning player versus player game, in the end of the day. And there's a kind of a worry that the more hardcore players wouldn't necessarily like this idea, or maybe we would alienate that group of players by doing so. So yeah, here's the. So after a bit of a thought, bit of thinking, bit of outsider, you know, opinions as well. We decided, yeah, let's go crazy, and yeah, fuck it, let's change the art style. It was like 2 months to the gold master, and the music too, and the sound effects. So back to the drawing board. So this guy here was the one that we had, and you know, we kind of like, you know, more aggression, more spit, more sweaty, you know, not so cutesy, not this kind of guy. So it started to go into really right direction, and also. Also, the icon is back in there. You know, we really want to get that spit in, the kind of manly, like, and then we did the first ZBrush sculpt. By the way, ZBrush is a brilliant program. It's unbelievably good. You could sculpt things really, really easy. So when I saw this the first time, one of our artists did this, and really, really good artists. So I literally, everybody said like, yeah, this is it, and then just kind of hand painted on, you know, kind of like on Photoshop first, and then texture it, and then we started to finally we had the barbarian. It was a really, really big relief. Start to create 3D model materials for this. We used the mental ray shaders, you know, the normal shenanigans, global illumination, you know, things like that. We also had the lighting rig. It's almost the same as we use to render in-game game assets. So from there on, it was pretty straightforward. Yeah, let's ship the thing. We also, at this late stage, we also included the Pekka character. It was a bit homage to a game called Backyard Monsters. Music and sound effects were also changed at this particular time to suit more adult style. The cannons used to go boing, and now they were like boom. So a bit like that, or kind of mixed crossfade between those two. So this was really a kind of like in a way, like a Pixar approach. You know, this character now, I'm going back a bit, this character now had a bit of double coding in it. So I think it really hit a sweet spot in a sense that it also appeals to a younger audience, but it doesn't really alienate the hardcore players. So this was pretty happy with that. So yeah, boom, out the door. That's it, the end. No. It's only really the beginning, because I have 30 seconds on the clock. We're constantly making Clash of Clans to be a better game, creating new characters, content. Look at this guy, it's awesome. So we're also not afraid to kind of press the hockey stick to like a Finland versus Sweden. We really want to focus this, and you know, now we have the opportunity to finally do it so stay tuned for more. And also, yeah, we're hiring too. Look at this. www.supercell.net, not com, and 1 second, boom, that's it. Thank you.
Okay, thanks, Lasse. That was awesome. Next up is Juha Tukkinen, who is the Tegra Systems Software Manager at NVIDIA Finland. And according to his own words, he's a humble servant for a team of international kernel superstars.
Testing. Hi, I'm Juha from NVIDIA. I'm the only Juha there. But there's more of us in Finland these days, over 50 of us, and this is a shameless ad if you, after this, feel like the urge to help us out. I'm hiring. So, what I'm going to talk to you about today is about graphics. This has been a graphics conference, my first time here, thanks for being invited. It's a story about how do you actually get something on the display running Linux. I don't want to get on Slashdot. This is not an announcement. I've already been on YouTube. That's another story. I'm going to really tell you what is to get this thing done, get something actually visible on the screen, and how hard can it be. So also a disclaimer that we actually ship products, stuff already works, so this is just getting stuff to Linux mainline. So hands up if you know what Linux is. Good, few. Okay, so then I'm going to skip that part and go directly to what Tegra is. This is not a shameless ad. Our ad agency didn't make this slide. I actually did it with Beamer. It sucks, but look the simplicity. So Tegra, it's small. It's incredibly. It's smaller than my finger's nail, but still it has a quad-core CPU, so it has 1,000 times more horsepower than my first PC that I also did my graphics demos on my free time instead of drinking beer, which is I do more these days. It also has a GPU, us being NVIDIA. It can play full HD video. It has crazy performance per watt. It's just crazy good. So some of the Tegra products that we're doing, you might have heard of these. Google Nexus 7, I got one, but I also have an iPad. Sorry, guys. HTC One X and X Plus, there are super phones. Then you have the Transformer Prime tablets and even some small cars, very cheap. So talking about the actual stuff, so how hard can it be? So I went through some Git logs, and for the past year, if you take a look at the Linux kernel mainline, so there are 750 patches related to Tegra support in only the last year, from tens of different contributors from lots of different companies, not only NVIDIA, tens of thousands of rows of code. So this actually makes us one of the top contributors overall to the Linux kernel. And I'm just project managing the project and not capable of writing much code these days. I can still review some of it and try to fix some bugs, usually with nasty side effects. And as a motivational thing, we also got one finger in the process. So those who you know this will know whom I mean. Thanks for that. And what works today? So this might not scale well as a demo, but here we have a Tegra-based laptop running fully open source code from the mainline, starting from the bootloader and everything. It's a Ubuntu desktop, works with software rendering, wireless LAN works. So here's the Slush web page, HDMI output, It almost works, so that's why I try to demo it. Parts of the power management obviously works because I'm not running it on mains view. But how do I then get to the real stuff? So software rendering is not our primary business. So this is where it gets hairy. So hands up those who really understand how graphics in Linux under X work. 1, 2, 3, 4. Many NVIDIA guys. Okay, so you need an X driver that uses our open source stuff. Well, we don't have it yet, so if you have some free time, I'll buy you a beer if you fix it. So, but what we have is that we have a new user-space 2D library in the works. It's about a couple of thousands of rows of code that actually can do blitz and flips and stretches and stuff. So what it actually does, it sends these streams to the kernel space magic. So this is where it gets more hairy. So this Tegra DRM was just approved, was it yesterday, to be a part of the mainline kernel 3.8. You do need a bit of more code from Finland in order to get anything sensible working. So it's about 10,000 rows of code, and one of my guys is about to propose it in 2 patches. So that might not fly, but let's see what happens. So this is the actual beast that feeds the command buffers to the real hardware, the lowest level graphics hardware called host, so which then again speaks to the actual 2D unit, etc. So this is actually a bit more complicated than I thought when I came to work for NVIDIA. So if I would have known this, I wouldn't have promised that, yeah, sure, we'll just upstream it and get it done. Well, the beast also needs like some hairy things like memory mapping, that you need to be able to allocate contiguous areas of memory and not to do anything silly about it. And in order to get anything in the screen, you need really weird stuff like power sequencing. This actually means that you have to turn on the display to see the pixel on the screen. It started with 7 rows of code to just turn on the display. But then somebody in the Linux upstream community said that this is not a scalable way for all possible displays in the world. We're like, oh, yep. So one of the guys spent a few months writing this perfect mechanism to enable turning on the display so that it has a separate configuration file in the device trees. And yesterday he got mail, now this is too complex, we don't like it. So working on getting the display up. Sometimes the small things can be a bit difficult. Of course, you need like other stuff like I2C support, talking to certain buses that you can actually ask from the display that what size you are, where are you, how are you doing. You need regulators and clocks to have anything working in the first place, have power working and clocks to give their spin to the life. So I thought that in 10 minutes I wouldn't actually try to demonstrate how it like all really works, but I went away yesterday and asked my guys to prepare a demo of all this actually working. And this must be the ugliest demo, which is the most complex one in the world also. Let's see if I get it working in 3 minutes. The plot thickens. So those who can actually see it, there's the bootloader doing something silly. The display is already on. The power management works. The quad-core CPU is alive. At least it was. It's loading the Linux kernel, unpacking it. It shows that there are 4 cores. You see the little penguins there? And then it does something for a while that I don't know, and I bet you don't either. But soon, we will have the most advanced graphics demo in Slush. So, it's this fun, it's also very easy. So all you need is the Tegra reference manual, read it and whip it, learn it by heart, join the IRC channels, join the mailing list, do a couple of patches, get, let's say, 4 or 5 merged to the main line this year, and you're hired. Thanks.
Whoa. Okay, and then last but not least, we have Borgar Ljosland. Borgar was the founder and CEO of Phalanx Microsystems, which created the Mali graphics architecture, and the company was acquired by ARM back in 2006. And since then, he's founded yet another graphics hardware company, and he's the current CEO of FXI Technologies, and he's going to be talking about cotton candy.
Thank you, Willie. So the history is actually a little bit more complex than that. So in Phalanx Microsystems, we developed the Mali GPUs that we licensed to system-on-chip vendors. When we got acquired by ARM in 2006, we made a deal with them that we spun out a particular patent, and that patent was all about how to do application processing on a memory device, such as a SD card or memory chip or a USB stick. We are waiting for the presentation to come up. Actually, there's not many slides, so I'll just continue to talk. Okay, thank you. The thing that we are looking at today is, what Gartner is predicting to be a big change in our lives. I don't know exactly what the personal cloud actually means, but it has something to do with more and more compute cycles being moved out there to some servers running some web apps, and the main UI that you're using is HTML5, and it will solve all of the cross-screen user experience challenges that we are having today as consumers or businesses or whatever. One of the key challenges, though, I'm a hardware guy by heart, and I laughed at Java. Sorry, but software doesn't solve anything when it comes to user experience. In the end, there is some hardware components that drives your pixels out there. There is hardware components that will offer you the performance that you will need, and everything on top of it is actually just APIs, interfaces, and accesses to this hardware. So the main challenge is still going to be huge fragmentations of compute on all of the different screens, and it's going to be a huge, even bigger fragmentations of the number of APIs, the number of operating systems, and the number of platforms that we have to relate to. In this world now, people are referring to it as a four-screen world. So we have, our mobile phone, obviously our smartphone, we have our laptop, we have a TV, and we have a tablet. And actually, we have more variations of these as well. People usually have more than one TV at home and so on. And these devices, these screens, they are tightly integrated with some kind of a compute resource. It's a chip, a system on chip in them that offers, the CPUs, and it offers more and more graphics processing. But the devices themselves, the screens themselves, they live very different lives. So the mobile phone here in Finland, Norway, and in the northern part of the world, we replace them on average every 12 months. In the US, it's every 24 months. And it's been, taking over as the device that most closely follows Moore's law. Every time you buy one, it has doubled or quadrupled in performance, depending on what you're measuring. The laptop, now people are replacing it every 3 to 3.5 years. It's slowing down a little bit. The TV set, it lives in your living room for 6 to 8 years. And the tablet, nobody really knows, depending on whether you have an iPad or something else. The point is that these are heterogeneously. They are out of sync when it comes to performance. So it's not possible to deliver a consistent, whether it's HTML or native user experience across all of these screens. So being a game developer, you simply cannot do it. There's one even worse thing about it, and that's that these screens, they typically belong to different ecosystems. You have Android, you have iOS, you have Windows, and you have Linux, and you have variations and SKUs of this across the devices, depending on which time and month they were launched out in the market. And that means that you have a massive variation in SKUs of your application as well if you want to provide a consistent user experience. The only solution to this, if you are a developer, is basically to target the least common denominator of all these devices, to create snake or something like that, because that will offer you some kind of consistent compute and performance experience across all of these devices. Doing anything more advanced than that is not going to scale easily across all of these devices. So what we are proposing is what we call the cotton candy. So it's a USB stick-sized computer, which today it sports a dual Cortex A9, 1.2 gigahertz CPU. It's built in a gigabyte of DRAM, has a quad-core Mali 400 GPU in it, so fully OpenGL 2.0 capable computer. It also has built-in Wi-Fi, so it connects obviously to the internet, and also Bluetooth, meaning that you can use most off-the-shelf accessories like keyboards, mice, and all of these things. It runs today either Android, which people can download from our SyysGraph.com development forum, or it runs Ubuntu. So we have an alpha release of Ubuntu running on it as well, 12.04. Now, on one side of the cotton candy, you have an HDMI port. And that HDMI port obviously plugs into HDMI ports, like TV sets or computer monitors. On the other side, you have a USB port. You can use it as a memory stick if you want to do that, but it also allows you to output the frame buffer produced by this device to any USB-capable screen or system, like a laptop or Windows or Macintosh laptop, or even other types of, any type of computers that do not have a TV in but have a USB port. So this is what we call the any-screen computing. It means that you can move this computer with its full operating system to screen, from screen to screen, and you have your whole compute environment OS with you at all times. We made a little video so I can catch a breath. I don't have sound.
Every device has them. Like your desktop. Sure, it's powerful, but you can't take it with you. And you can't use different OS hardware or networks. And you can't fit it in your pocket or take it out in the field. Mobile devices are, well, mobile. But you still can't escape their ecosystems. And you can't enjoy great HD game graphics on that little screen. And the IT guy says you can't use it on the company's secure networks. But what would it look like if you had a powerful, portable, and secure device that worked in any ecosystem, and it worked on any screen? It looked like cotton candy. This sexy, powerful microcomputer frees you from cant bubbles. Whether at home, work, or in the field, cotton candy functions as an ideal cloud computer, keeping your private stuff private. And it works on any screen, even ones like this. The power, portability, and versatility of cotton candy makes it whatever you need it to be, wherever you are. How will you use it? Visit www.fxitech.com today.
So we're planning to do a little demo, and I have 2 minutes, so that should be possible to do. So what happens when you plug this into a computer? It shows up in the UI of that computer as a memory device. There's no drivers required. When you open up this memory device, there is an open partition that can be read, a FAT32 partition. It contains some virtualization client that you can launch. I launched the one for Mac OS X here. This is still in a beta mode, so it's a kind of a developer focus for us right now. But when you have the UI up there, you basically connect to the cotton candy. So what you see on the screen now is basically the frame buffer produced by the device itself. Sorry about that. The OS, in this case Mac OS X, doesn't know anything what's going on. It thinks it's a memory device still. And I have not decided yet what demo I was going to run, so we have preloaded some of the applications here. I'm a little bit tempted to do something with music, but this one is probably the one that's talking to the point of bringing powerful graphics to any screen. It's developed by a company called Outrax Technology, offspring from a Norwegian demo group. It takes some time to load, meaning that I can... Oh. It might take more than 1 minute to load. No, it's coming. So it basically shows off some of the capabilities. We still have some optimizations to do in terms of getting the full graphics pipeline to run, but it's capable of doing this type of graphics in 1080p video. Right now, I think it's 720p, at least downscaled to my Mac. They do a lot of interesting stuff. For instance, the signature Mali 16x full scene anti-aliasing. A lot of per pixel effects, real-time shadows, and so on. It's actually playable as well, although it's not that entertaining in the long run. I've been doing it too many times right now, but here we are. Yeah. So I think I have 4 more seconds, so thank you very much.
Okay, thanks everyone. This has been a great day. I think we're going to be kicked out of this room. There is something else, something non-graphics related starting in this room, but you all have badges that will let you wander the rest of Slush over there. We should be having, I think, drinks and snacks and whatnot, and if you stick around for a while, at 9 o'clock, SuperCell is throwing a huge party, and you're all invited. Thank you.